Hello, my students in grade 8. In mathematics, this is lecture 10, and the title of our lesson is Equations in the Form of ax plus b into cx plus d equal to 0. What are the objectives of this lesson? Number 1, as a reminder, solve simple equations. Number 2, identify special equations. Number 3, solve an equation in the form of ax plus b into cx plus d equals 0. And this form of equations, we call it a product equation. As a reminder, what we studied before about equations. Define an equation. An equation is a mathematical statement that two things are equal. It consists of two expressions, one on each side of an equal sign between them. So in an equation, we have side 1, we have side 2, and we have an equal in between. In each equation, we have a variable or unknown called x. Why do we use equations? We use equations in order to find a root or solution for the variable x. So a real number x, which is the unknown or the variable in the equation, will be called a solution or a root if it satisfies the equation. So for example, if we are given an equation, in this equation, we have a variable x. This variable x has a value in numbers. It has a numerical value. So we will be given the equation and we will be given the numerical value of x. To verify that this given value is a solution or root of the equation, we replace the given value of x in the equation. What do we mean it satisfies the equation? After calculation, if we get two equal sides, then this root or this value is a root or a solution of the equation. Solve equations in the form of ax equal b, then the solution will be x equal b over a. We will be given equations of the first degree. However, the form of the equation is, in any form the equation written, finally, in the final step of the equation when solving, I should have a simple equation form, which is ax equal b. X is the unknown, a is a negative or positive number, it's the coefficient of x, and b is a constant or a fixed number, it can be positive or negative. So when the equation is written in the form ax equal b, we say that this form is a simple equation form. Now we can find the solution or root, so directly we write x equal b over a, whatever b is, whatever a is. And our fraction b over a should be irreducible. For example, we are given x minus 7 equal 3. This is an equation. On side 1, we have x minus 7. On side 2, we have 3. And in between, we have an equal. The variable or unknown in this equation is x. To solve this equation is to get a solution or root for x. So the equation should be written in the simple form. So first I ask, is this a simple equation form? No, it's not written in the form of ax equal b, since here we have minus 7. So how do we write it in the simple equation form? We say all x should be on side 1 and all numbers should be on side 2. So x, I keep it on side 1, and minus 7, I take it to 3 on side 2. But when I take from side to side, I should change sign. So minus 7 becomes plus 7. So x equal 3 plus 7, so x is equal to 10. Now I'm given the equation 2x equal 8. Is this a simple equation form? Of course, because this is ax equal b. So directly the root is x equal b over a, then x equal 8 over 2. We can reduce, then x equal 4 is the root or the solution. Always our root, we put it in a box. Minus 7y equal minus 21. So this is a simple equation form. A is -7 and B is -21. So the variable y equal B over A -21 over -7. So y is equal to 3 in a box. -5x equal 15. This is the simple equation form ax equal b. Then the solution x equal b, 15 over a minus 5. We can reduce, so x equal -3 is the solution. -4t equal 11. The variable is t. This is a simple equation form, so t equal 11 over -4. We cannot reduce, so this is our solution or root. Special cases of solutions. Whenever we write an equation in the form ax equals 0, we ask, what should x be if multiplied by a to give me 0? Then x should be 0. So always whenever we have, for example, 2x equals 0 minus 5x equals 0, directly we say the solution is x equals 0. 0x equal b, this equation has no solution. Why? Because whatever the value of x is, when multiplied by 0, it never gives me a number. It always gives me 0. So this equation has no solution. 0x equals 0. Whatever x is, if we multiply it by 0, it always gives me 0. So here x has many solutions. X minus 7 equal 2. So x on side 1 and we take the -7 to side 2, it becomes +7. So x equal 9 is the solution. 2x minus 3 equal 5. So 2x equal 5 and we get the -3, it becomes +3. So 2x equal 8. This is a simple equation form. So x equal 8 over 2, then x equal 4. 3x minus 4 plus x equal to x minus 2. We keep 3x on side 1, we keep plus x on side 2, and we get 2x to side 1. Here it's missing plus x. A typing mistake. Let me correct it. So here we also have on this side plus x. Sorry, let me go back. Plus x. Okay, so 3x plus x is how much? It is 4x minus 2x. So we get 2x is equal to 2. Then the solution is x equal b, which is 2, over a, which is 2. So 2 over 2. Then the solution x is equal x equal 1. This is our solution. So this is a typing mistake and I corrected it. So x is equal to 1. This is our solution. Let me continue. Now we have 2x minus 5 equal to x plus 4. So we keep 2x on side 1. We get the 2x to side 1. It becomes minus 2x equal 4. And we get the minus 5. It becomes plus 5. 2x minus 2x is 0x equal 9. So this is a special equation. So 0x equal 9 has no solution. Y minus 2 plus 4y equal 5y minus 2. So y plus 4y minus 5y equal -2 plus 2. 0y equals 0. This y has many solutions here. So this is how we solve these simple equations. Let me clear now. Clear all drawings to continue to the next slide. Now, equations in the form of ax plus b into cx plus d equals 0. As you can see here, this equation has two sides. Always on the second side, we should have 0. We should not have 1 or 2 or -5. No, always here should be 0. And on side 1, we have two parentheses multiplied together. If you still remember, when we have two parentheses multiplied together, we say this is written in factorized form. So a product equation, on the first side, it should be factorized. On the second side, we should have 0. Now, how we solve the equation in the form of ax plus b into cx plus d equal to 0. This equation admits or has two solutions. Why? Because either the first binomial ax plus b is equal to 0 or the second binomial cx plus d is equal to 0. When one of these two binomials is equal to 0, then all the first side will be 0. Let us solve the first one. Ax plus b is equal to 0. Then ax equal minus b. We take the plus b to the second side. Now x equal minus b over a. Or if cx plus d is equal to 0, then cx is equal to minus d, then x is equal to minus d over c. So always a product equation has two solutions. This is the first solution. This is the second solution. Let us solve examples. X plus 1 into x minus 2 is equal to 0. Why is this a product equation? Since on the second side of the equation we have 0 and the first side is written in factorized form. So directly we say x plus 1 is equal to 0 or x minus 2 is equal to 0. If x plus 1 is equal to 0, then x is equal to minus 1 is the first solution, and x minus 2 is equal to 0, then x is equal to 2 is the second solution. So this equation has two solutions. Another thing, if you look here at this equation, x, if we multiply it by x, if we expand it, we have x squared. So since the degree of x is 2, then it has two solutions. So always a product equation is a second degree equation. That's why it has two solutions. 2x minus 1 into x plus 5 is equal to 0. Also, this is a product equation since the second side is 0 and the first side is factorized. So 2x minus 1 is equal to 0 or x plus 5 is equal to 0. If 2x minus 1 is equal to 0, then 2x equal 1, then x equal 1 over 2. X plus 5 is equal to 0, then x is equal to minus 5. As you can see, always the first side should be factorized and the second side should be 0. Now, the equation in the form of ax plus b into cx plus d is in factorized form. We can solve it directly, but some of the equations need to be factorized before solving them. To factorize, of course, as we did in our lesson, factorize an algebraic expression, either we use remarkable identities, the first, the second, or the third, or we use the common factor way. Now, let me continue. For example, if we have x squared plus 6x plus 9 equals 0, the second side is 0, but the first side is factorized. Since the first side is expanded, so we should factorize it. We always ask, how many terms do we have? We have 3 terms. Is there any common between the 3 terms? No. So we cannot factorize using common factor. We factorize using remarkable identity. Since we have 3 terms, so either we use remarkable identity 1 or remarkable identity 2. Since the second term is positive, so we use remarkable identity 1. So here we see a squared plus 2ab plus b squared. The factorized form of this is a plus b all of it squared. So the root of x squared is x plus the root of 9 is 3, all of it square is equal to 0. What does this mean? X plus 3 into x plus 3 is equal to 0. So here we have a double solution. We have x plus 3 is equal to 0, then x is equal minus 3. This is called a double solution. Now we have y squared minus 4 equal to 0. This is an equation of the second degree. So the second side should be 0 and the first side should be factorized. So the second side is 0. We continue to the first side. Is the first side factorized? No, it's expanded. So we should factorize it. How many terms do we have? 2 terms. Is there any common between the terms? No. So we use remarkable identity 3. Here I see a squared minus b squared. So the factorize is a minus b into a plus b equal to 0. Y minus 2 into y plus 2 is equal to 0. Now this is a product equation. So either y minus 2 is equal to 0, then y is equal to 2, or y plus 2 is equal to 0, then y is equal to minus 2. So these equations, we need to factorize them before solving. Now, x plus 3 into 2x minus 1 plus 4x squared minus 4x plus 1 is equal to 0. In this equation, the first part is factorized, the second part is expanded. So we need to factorize the second part. 4x squared minus 4x plus 1. Here, do we have a common factor between the terms? No. So we use the first or the second remarkable identity. Since the second term is negative, so we factorize it using the second remarkable identity, which is a minus b, all of it squared. A squared is 4x squared, so its root is 2x minus the root of 1 squared is 1. Now, here we have x plus 3 into 2x minus 1 is the first term, and 2x minus 1 squared is the second term. What's common between the terms? We have a binomial 2x minus 1. If I divide the first term by 2x minus 1, I'm kept with x plus 3 binomial, plus divide 2x minus 1 squared by 2x minus 1, we get 2x minus 1 equal to 0. We write our answer between a bracket. Now, in this step, we get rid of the bracket. The 2 parentheses, we put them in 1 parenthesis. X plus 3 is multiplied by the positive before it, and 2x minus 1 is multiplied by the positive before it. Now, we reduce this parenthesis. X plus 2x is a 3x. Plus 3 minus 1 is 2. Now, this is a product equation equal to 0. Either the first parenthesis is equal to 0, we solve it, then we get x is equal to half, or the second parenthesis is equal to 0, we solve it, and we get x equal minus 2 over 3. So since this is a second degree equation, it has 2 solutions. Please practice these exercises to understand well. Now we have a variety of questions. I'm solving some of these questions with you. Verify whether the given number is a solution of the given equation. So we are given an equation x squared plus 2x plus 1 is equal to 0. And we are given a solution x is equal to minus 1. To know if x is equal to minus 1 is a solution of this equation, we replace it in the equation. We should get 2 equal sides. So after replacing and calculating, we get 2 equal sides, then x equal minus 1 is a solution. Practice this exercise, it's very important. Now here we are solving different kinds of equations. Let's solve the first one. 2x squared plus 3x is equal to 0. The second side is 0. Is the first side factorized or expanded? Expanded, so we should factorize it. First, I ask, how many terms do we have? 2 terms. Is there any common between the terms? Yes, we have a common x and we factorize. So we get a product equation equal to 0. So either x is equal to 0, this is our first solution, or 2x plus 3 is equal to 0, then x equal minus 3 over 2. And you can continue solving the other examples. It's very important to solve these exercises. Also here we have solving equations. 2y squared minus 8 is equal to 0. Is there any common factor? Yes, we have a 2. So 2 into y squared minus 4 is equal to 0. Please pay attention. Inside the parentheses or our binomials should not be second degree, should always be first degree. So whenever you see a binomial which is second degree, you should say that we can still factorize. Y squared minus 4. How many terms do we have? 2 terms. Is there any common between the terms? No. So we factorize it using remarkable identity 3. Here I see a squared minus b squared. So I write 2 into A is y minus and B is 2. Y minus 2 into y plus 2 is equal to 0. So this is a product equation. Of course, 2 is not 0, so we do not take it. Y minus 2 is equal to 0, then y is equal to 2. Or y plus 2 is equal to 0, then y is equal to minus 2. Please solve. The others are very important. Also, these exercises, I solved like them before. We should factorize, then we solve. So we should factorize. If you look here, we have two terms. This is not factorized since we have a minus between the terms. So what's common between the first term and the second term? We have a binomial x minus 5. So we solve it until it's a product equation equal to 0, then we solve it. You can solve the other examples. Also, here we have this equation. The second side should have 0 on it. So x squared plus 6x plus 9, let's factorize it first. It's x plus 3, all of it squared. We take it to side 1, so it becomes minus equal to 0. Now the second side is 0. Is the first side factorized? No, because in between the terms we have a minus. So what's common between the terms? It's x plus 3, so we factorize it until we solve. This was our lesson for this week. It's a very important lesson, the equations, and it's a very easy lesson if you practice the solved exercises in the video. Please watch the video well and practice the exercises we solved before the vacation to understand more. Thank you.